Welcome to solverfy.
Okay, so problem number 66. It wants us to, we have two particles. We have basically that decays, that shows this particular decay path. So you have some original particle and it decays into two new particles given by these two mass energies, rest energies. We want to show that the kinetic energy of particle 1 is equal to, so K1 is equal to 1 over 2mc squared times mc squared minus m1 c squared squared minus m2c squared squared. All right, so to do this, we need to start with first the conservation of momentum. And that makes it so from conservation of momentum, this side is at rest and it's a decay. So that means that the total momentum on this side is 0, which means the total the magnitude of the momentum on this side, I'm sorry, the total momentum on this side has to be equal to 0, which means that the momentum of particle 1 has to be equal in magnitude but opposite in direction of the momentum of particle 2. So we can say P1 is equal to P2. Now, from the relativistic energy equation, E squared is equal to PC squared. You know, I'm going to write this on the other side to give myself some more room. So the relativistic energy equation is given by E squared is equal to PC squared plus M squared C to the fourth. And then rearranging that for PC squared, you get PC squared is equal to E squared minus M squared C to the fourth. Okay, so now from that, we can put this in the terms of P1C squared is equal to P2C squared. Now, the total energy, we can use conservation of energy. Now that we have the conservation of momentum laws, we can use the conservation of energy laws to state that the total energy on this side, the left-hand side, is going to be equal to the total energy on the right-hand side. So we have E0, which is the total energy on the left-hand side, which is just equal to the rest mass, the rest energy of the original particle, is going to be equal to E1 plus E2. Okay, now we can rearrange this a little bit and show that E2, giving myself some more room, I'll come over here, E2 is equal to M0 squared, C squared, minus E1. Okay, so now we have excuse me. So we have now the equation of P1C squared equals P2C squared. So where P1C squared is equal to, is going to be equal to E1 squared E1 squared minus M1 squared C to the fourth, and P2C squared is equal to E2 squared minus M2 squared C to the fourth. Okay, so now we can plug in what we know. So E2 is equal to this. So we have E2 can be given by this. So we have E2 squared is going to be equal to M0C squared minus E1 squared which is going to be equal to P2 squared C squared plus M2 squared C to the fourth. So that's E2 squared, which is also equal to this. So I will go ahead and put this in red. Okay. So now we can state that P2 is from conservation of momentum. Put this in green. P2 squared is just going to be equal to, let's do this, from conservation of momentum is just going to be equal to P1 squared. So we can then plug that in. So this is going to be equal to P1 squared C squared plus M2 C to the fourth, M2 squared C to the fourth. Okay. Now, also, from, let's see, I'm going to change colors. I haven't used blue yet. From this relation, we can plug in this expression. Okay, switch back to black. And now we have M0C squared minus E1 squared is equal to E1 squared minus M1 C squared C to the fourth plus M2 squared C to the fourth. All right, now we need to expand this, expanding. So now we have M0 squared C to the fourth minus 2 M0 C squared E1 plus E1 squared is equal to E1 squared minus M1 squared C to the fourth plus M2 squared C to the fourth. All right, so these guys cancel. And now we can rearrange this. I'm going to create a new page, so I'm out of room. I'm going to rewrite this. So we can rearrange this. We want to solve for the E1, so the energy of particle 1. So we're going to rearrange this to have that, to do that. So that next step is going to be 2 M0C squared times E1 is equal to M0 squared C to the fourth plus M1 squared C to the fourth plus M2 squared C to the fourth. Okay, so see what I did? If you don't, I moved this guy over and then moved everything back over to this side, so just collected terms. And that's it. So now we can solve for E1. E1 is equal to M0 squared C to the fourth plus M1 squared C to the fourth plus M2 squared C to the fourth over 2M0 C squared. So M's, C to the fourth, okay. Now, from the kinetic energy, so for E1 is equal to K1 minus plus M1 C squared, and K1 is equal to E1 minus M1 C squared, and we want to know this, we want to solve for the kinetic energy for K1, so now we have K1 is equal to E1, which is this term here. So m0 squared c to the fourth plus m1 squared c to the fourth plus m2 squared c to the fourth divided by 2m0 c squared minus m1 c squared. So now we just want to combine all this. So k1 is equal to m0 squared c to the fourth, 0, plus m1 squared c to the fourth, plus m2 squared c to the fourth, minus 2, sorry, I don't know why I wrote 3, 2 m0, m1 c to the fourth over 2 m0 c squared. You don't see what I just did here? I just multiplied top and bottom by 2 m0 c squared in order to give it a common denominator, and then I could just combine everything. So now I would normally pull out a c squared and put this all in combined mass terms, but in order to have it in terms of what the, for the problem, we can just k1 is equal to 1 over 2 m0 c squared times, now if you look, here I'll just do it slowly here, I'll combine some, I'll put this in a form that's going to make sense. We have m0 squared c to the fourth minus 2m0 m1 c to the fourth plus m1 squared c to the fourth plus m2 squared c to the fourth. Now if you look at this term here, this is just gonna, you can factor this, you can reduce that. So now we have k1 is equal to 1 over 2m0c squared times m0c squared m0c squared minus m1c squared I'm running out of room, minus m2c squared squared. So I'm going to create another page so I can redo that, just so it's easier to see. All right, so we have k1 is equal to, so don't, where am I at here? K1 is equal to 1 over 2m0c squared times m0 squared c to the fourth minus 2m0 m1 c to the fourth plus m1 squared c to the fourth plus m2 squared c to the fourth. Okay, so like I said, that's, you can factor that. So k1 is equal to 1 over 2 m0 c squared times m0 c squared minus m1 c squared squared plus m2 c squared squared. QD, meaning we have set out to prove what we wanted to prove.